good morning, depending on where you are. So yeah, before we get started with the talks tonight, I wanted to give a quick presentation of Pydata, and especially this Pydata Paris meetup. So Pydata in general, it's a community for developers and users of open source data tools. So if you are interested in more events like this one, follow us on Twitter. You can find us with the Pydata Paris handle. So Pydata is actually a trademark and an educational program of NumFOCUS. So NumFOCUS, I don't know if you know it already, but it's a nonprofit promoting accessible and reproducible scientific and technical computing. It actually serves as some kind of umbrella organization for open source projects such as NumPy, Jupyter, Pandas, Scikit-learn, and many other projects of the community. And it really simplifies actually raising money and getting grants for developing these open source projects. And Pydata is one of the main programs that they have. So first we have Pydata conferences. So the conferences are multi-track, multi-days conferences on open source scientific computing. We have such conferences in Berlin, New York City, Budapest, Eindhoven in the Netherlands, Los Angeles, Austin, Warsaw, and many others. Some of them have thousands of attendees. One of the biggest ones is actually Pydata London in Europe. Since 2020, we've been holding Pydata Global, which was for the first time an online event and fully online event. And so that went really well. Beyond the conference, we actually have Pydata meetup groups. So in 66 countries, there are 186 groups, which together account for over 180,000 members. So that's really a large community. So in Paris, the Paris chapter of the Pydata meetup. So today is the 15th event since May 2017. We have over 3,000 members. We got 24 talks since the beginning, and we are always looking for venues, speakers, and sponsors for catering or flying invited speakers to Paris. So we have a code of conduct. So we strive to make Pydata an inclusive and welcoming community for everyone. So if you want to read the complete code of conduct, you can go to the numfocus.org website. I provided a link in the presentation. But the short version is, please be nice to others. Do not insult anyone or put anyone down. Behave professionally. Remember that harassment and sexist, racist, or extra-generic jokes are not appropriate for NumFOCUS. So I've included like more content, but like the short version is like, please be nice to each other. If anything happens that to you or someone else that you witness and makes you uncomfortable, you please do not hesitate to contact the local meetup organizers. So myself, Emmanuel Jacobowitz, or Sébastien Fréal-Saison. Or if you're even uncomfortable with telling the local organizers about something that happened, you can directly contact NumFOCUS, the foundation, with an online form or by email. So I provided the form link in the presentation and the email address if anything happens. So I just wanted, since this is the very first time that we're holding this Pydata Paris meetup since the pandemics, I wanted to tell you a bit more about the future of Pydata Paris. So why are we doing like this? Why have we been organizing this meetup for like over 3 years now? One of the main goals was to gather the Paris, open source data science community and get them to meet and have a place to exchange ideas. And unfortunately, we didn't have any event in 2020 because of the sanitary situation. But hopefully we'll get back to normal by the end of the year with in-person events every 2-3 months. So we are already looking for sponsors and people who may want to host a meetup in Paris. So tonight we got quite an interesting number of speakers, and we're going to start with a keynote by Roman Yurchak. So Roman is a data scientist and founder of Simerio. He has a background in physics, and he's also an active open source contributor. In particular, he's a core developer of the Scikit-learn and PyOdide project. So now I'm going to leave the stage to Roman.
Thank you, Sylvain. So let me share my screen. Does this work? Can you see my screen?
Yes, everything.
Okay, great. So thank you, Sylvain, for organizing this event. And today I'll start by a talk on PyOdide, which aims to bring scientific computing with Python to the browser with WebAssembly. So what we'll talk about today is we'll start with this overview of the project, a bit to discuss the features it has, the limitations we have, or the what you can do with PyOdide. We'll talk a bit about more concrete applications, and finally we'll talk about challenges and the current roadmap. So during this talk, if you have any questions, please, I think there will be a time where you will be able to comment on Zoom. So.
You can already actually post in the chat.
Okay, thank you. So let's start with a bit of an introduction of WebAssembly. So what's WebAssembly? It's essentially a binary instruction format for a virtual machine. And initially, it was designed for browsers as a way to accelerate some kind of computation in the browser, where traditionally you would use JavaScript, but for some applications, JavaScript is not fast enough. So people there was a design to develop WebAssembly to respond to that use case. However, now you can also use WebAssembly in other standalone environments. So for instance, you can use it with Node.js, which runs on the server, or you can use it with the WASI. You can essentially just run arbitrary programs with WebAssembly. So why it's interesting is because it's portable. So portable means that you have the same binary that's going to run on any kind of operating system and or any kind of architecture. So for instance, nowadays you can maybe, you have maybe more processors that run IRM. For Century Python, it means they have to recompile packages for that architecture. With WebAssembly, you just have one binary that runs like everywhere. So it promises near native performance. Of course, you have some performance overhead, but essentially the idea is the performance is close enough. And it's sandbox. It means that you don't directly talk to the operating system. You have some kind of sandbox in between. So for instance, in the browser, it's going to be the same sandbox as for JavaScript, which is very thoroughly tested. So that allows some amount of security of the code you run on your machine. So what we have now is there are projects that allow you to take some C code or C++ code and compile them for WebAssembly. So for instance, you have mscripten project, which allows you to do that. So it would produce essentially a WASM binary file, and you add some JavaScript root code around it, and you can run that inside the browser. So it means that essentially that works for any kind of C code. And because, well, Python is written in C, like C Python, so that's what was done in PyOdide. So PyOdide is essentially, we take C Python as it is, so really the source code of Python. We compile it with mscripten. We do the same thing for different scientific Python packages that have C extensions. So for instance, if you want to compile NumPy, it's not just Python code, it also has some C code, and you need to compile it. And so all of that is converted to WebAssembly. And so now you have essentially an interpreter you can run, and you have some of the packages with C extensions that are available as well. And in addition, so what we have is there is implementation of a very small part of what pip does. So it allows you to install packages from PyPy. So you can this only works for Python packages, but it allows you to just load package that's in PyPy, you can load it in PyOdide and use it. And finally, there is the Python JavaScript type translation or foreign function interface. So what it allows you to do is to take say a Python function and use it in JavaScript, or the other way around. So of course you have the project repository below, and now I'll maybe do a short parenthesis on the project history. So the project started at Mozilla, was started by Mozilla at Michael Jordan, and initially it was a language plugin for PyOdide. PyOdide is a experimental notebook environment for collaborative and scientific computing communication. So unfortunately, the PyOdide project is no longer maintained, and since then the support from Mozilla has decreased a bit. So as of this year, we have become PyOdide has become an independent project. So it has essentially it's a community-driven project with the independent governance. We have a roadmap and a code of conduct. So of course there have been other projects that built Python in the browser. So one of them is, for instance, PyPy. So PyPy took was before PyOdide, and the approach they took was very similar, except that they used ISM.js at the time, which was the precursor of WebAssembly. And so this project is no longer maintained, but it's completely possible to do this for instance, for PyPy. So there's other approaches such as Breton. So Breton is really a re-implementation of the Python interpreter in JavaScript and of part of the standard library. Same, you have the Rust Python, which is a re-implementation of Python in Rust, and because Rust builds nicely to WebAssembly, you kind of get that mostly for free. And other projects such as MicroPython ports, which builds MicroPython to Rust. So the general idea is that it's possible. It's like there are many ways to run Python in the browser. That's fairly. There are many projects do that. The difference of PyOdide is that beyond Python, what we would like to do is to actually be able to use the Python ecosystem in the browser. And the ecosystem is not just the interpreter. You have all those packages, including Casati packages, that have like C code or Fortran code or some other compiled extensions that you actually need to compile to be able to use. So let's talk about packages with C extensions a bit. So essentially, all the core scientific packages enter in this category. So you have, well, the core package is NumPy. Then once you have NumPy, you can compile, for instance, SciPy. But SciPy depends on BLAS, so it's a numerical computation library for matrix algebra, and BLAS and LAPACK. So and the challenge there is that you need some part of that is written in Fortran, and it's getting a modern compiler, like at least a couple of years ago, was really difficult. Now there's a lot of project with a lot of progress in this area. But so generally that's the idea. So the core packages are compiled, and I haven't put the full list here. We have over 75 packages which are natively included, and then you can add additionally parts. You can load packages from PyPy with micropip. So micropip works only if you have pure Python wheels that are uploaded in PyP. So in case you wonder, the difference is that a wheel is just a zip file with the source Python source files already directly included. So you don't need to run setup.py to install a wheel. You just unzip it and you can use it. And this means that we can actually use it directly in PyOdide. If you don't have if you have a pure Python package which doesn't have a wheel, we can't use it in PyOdide currently because it requires to run setup.py and essentially it requires to run pip, and that's not currently supported. That's the ideal case. Well, unfortunately, in some there are still some modules that are not supported by WebAssembly VMs, such as if you need sub-processing or multiprocessing, or if you try to use sockets, it's not going to work. So in this case, we have to patch essentially the project, for instance, to avoid the imports and some things like this. And so in this case, you can actually include the package as part of the PyOdide build system, which is vaguely inspired by CondaForge, and we're trying to migrate in the direction of better compatibility with CondaForge. So what we have now is essentially have a meta.yaml file. You can just write your setup there. And then, so these files are distributed by JSDeliver CDN, so you can essentially load them from relatively easily and efficiently when you need it. So that's the general idea, and we can also mention the type translation API between Python and JavaScript. This is really the part that makes it actually interesting to use PyOdide in a web page, because on one side, you can use JavaScript from Python. So, for instance, you have in this example, for instance, you have access to the DOM, so you have access to all the elements of the web page. So, for instance, you can import JS, which is a specific module of PyOdide, and there you can set for instance, the document document title, and it's going to change the title. So, and you do that from the Python side. So of course, some people saying, well, I don't like JS, I only want to use Python, and can I do that? So the answer is yes and no, because in the end, if you want to use Python, you have PyOdide, you have to have some knowledge, like you're going to get some notions of JavaScript as well. For instance, you can also use PyOdide the other way around. So from JavaScript, you can use some global Python object. Let me just hide this. Yes. So for instance, in this example, we explored the Python global objects. We take the sys module from there, and we created a JavaScript module that's like object that wraps this module. So maybe to be more concrete, let's do a short demo to illustrate a bit how we can use all this and what we can do with it. So let me try this. Okay. So what you have here is a REPL. So it's a PyOdide REPL, right? So it's a standard Python terminal. So you can do like basic Python. You can write Python code in there. So, right. So now we can also import modules as expected, right? So we can, for instance, we can export standard library modules. So here, the interesting part is that Python is essentially a bunch of files somewhere in the file system, and the question is, what do we have here? So, for instance, if you look at where this module is located, it's located in the /lib/python. And the thing is, for instance, I'm currently using Windows because Zoom otherwise doesn't work very well. And so essentially this file system is completely virtual. So it's an in-browser virtual file system that's provided by mscripting. And that's going to be essentially reset each time you reload the page currently. So, so of course it's a file system, so you can use usual Python operations in it. So for instance, let's look at files in there. I don't know. Okay, live coding is not definitely that easy, but so essentially you can do your usual thing, like the usual stuff you would do with Python in this WebAssembly VM, where you also have like something that looks like a file system. So now, interestingly, we can similarly load external packages. So by default, you're not going to load any of the like external packages. If we import, for instance, NumPy, so what's going to happen is that behind the scenes, PyOdide is going to fetch the PyOdide package from compiled for WebAssembly, the NumPy package compiled for WebAssembly, and so we can do like the usual, the usual operations with, for instance, NumPy. So similarly, you can also load. Do you see my screen well? Because it's at the bottom of the screen. Is it? Okay?
Yeah, it's just perfect.
Okay. Great. So similarly, you could, for instance, try to load packages from PyP. Okay? So to do this, we will import microclip. Okay, just a second. Let me try to hide this. So we will import the macroclip package, and what we'll install, for instance, like an arbitrary package. So say to do this, we'll do so what we did here, we installed the package which is called Snowball Stammer from PyPy. And we use the await syntax. So essentially, you can use async.io inside PyOdide as of this last release. And it's in this case, it's going to use the event loop that's run by the browser. So it's going to use essentially a JavaScript event loop to run async code with Python. And now that we loaded it, we can import it, and run some operations with it. So more interestingly, we can also define For instance, let's define some function, like a simple function in Python that does some kind of operations. For instance, takes a square. So this is a Python function. Now, what we can do is let's open a JavaScript console. So you have a JavaScript console here. By the way, it shows what you have loaded. Tell me if you don't see it, if you don't see the console. And so interestingly, we can now access this function, which is the Python function, from JavaScript. So what we'll do, let's define it, and then we'll do PyOdide. And so this function is actually a proxy, so it's a wrapper around our Python function. However, we can access methods of it. So, for instance, we can access all the usual Python methods, for instance, name, and we can also call it. So, for instance, we call tree, you name. So, what happens here is that you have this proxy object that you pass a JavaScript argument to it. The argument gets converted inside to a 9, so to an integer type inside Python. The function gets computed, and then you get the return back to JavaScript. So you have this bidirectional conversion that's happening all the time. And so, of course, in the other way around, you can similarly do. You can define some variable in JavaScript, and then you can access this from Python. Import x, and so here you have x, and the type of x is string. So you pass from a JavaScript string to a Python string. So that's a bit of an overview, and the fact that you have those conversions that work, this allows you to essentially do a lot of interesting applications using PyOdide. So let's get back to the presentation. Question one can ask is what about performance? So how fast is it? So what we currently have is PyOdide, like Python with PyOdide, is going to be between near native performance to 3 to 5 times slower. There have been a lot of improvement in the last version. So this is the last release, 0.17, but we're still noticeably slower than native Python. So there are some possibilities that are being explored, and it's possible to reduce this overhead further. Today, in later talks, you will hear much more about applications of PyOdide in terms of notebook environments and end user applications. I'll just briefly mention some. So we have the PyOdide wrapper, which I just showed you, which is essentially a very simple JS console, but it's sufficient to actually illustrate most of the functionality. We have the iodide project, which is how the PyOdide started. So it's an interactive notebook environment that's they can access here, but it's no longer supported. And then we have the notebooks environment. So, for instance, we have the Basthon, which is will be mentioned just after my talk. So it's a fork of Jupyter notebook, Starboard notebook, and Jupyter. Sorry, there's a typo. JupyterLite. Again, I'll skip them because we'll hear more about this just afterwards. But the general idea is that if you take a classical architecture between a front end and back end, so what you usually have is the user that talks to some web page, and this web page is going to send requests to some server that's remote, and the server probably has some Python code, or let's say a kernel, or generally some computational code that's going to run, that's going to maybe query a database and return the response. In the case, if you put actually your code into the browser, well, this allows you to run the computations directly there. So it means that, for instance, if you have a Python algorithm that computes something based on user input, you can directly compute it on the front end, and just maybe make some queries when you need the data. So the advantages and limitations of this approach are as follows. So in terms of usability, that's doesn't really change much, in the sense that you will be able to use Python code to run some computations without installation needed, right? Whether like you just go to a web page and you can run Python. A very big advantage is scalability. So you can, because essentially you're just serving static files, and now you have CDN solutions that allow you to do this at scale relatively easily. So in terms of cost, there is very little cost if you have, even if you have hundreds of thousands of users. It's going to be transparent for you. The computation is not, you don't have to deal with where I'm going to run the computation. So it's, in some use cases, particularly for instance education, as we'll hear later, it's a big advantage. Well, you have also potentially the privacy aspect, because since you run the calculations locally, you don't necessarily need to send the query somewhere to some remote server. You might still need to fetch some data from the remote server. And there's also the question of algorithmic transparency. So because, well, it's Python, so it's just in the end it's just Python scripts, right? So it's files you can inspect. So you can, if you have an application that runs your Python in somewhere, you can inspect it and you can see what's happening, especially that it's in the front end, so you have access to that. Of course, that can be an advantage if you're interested in this aspect, but it can also be limitations if you have some trade secrets you want to protect. And of course, we know that, like in the case of Python, that's problematic. You cannot really obfuscate your code. So if you do a small parenthesis on the case of machine learning models, how we deploy them. So for instance, if you take the classical workflow is, we take some machine learning model, we train it, we serialize it on disk, and here on the right you have like some of the most frequently used serialization formats. And then we're going to develop some web service around it to serve this to make predictions. We package it maybe in a container and then we deploy it on some server. And of course, if you could take your model directly and just directly run it inside the browser, assuming it's not too big, assuming that it doesn't require to download like hundreds of megabytes of data, that can simplify a lot of this deployment process. So, and there are already tools that allow you to do that. So for instance, you have on NX that does that's a standard serialization format that works really well. And then you have, like, for instance, TensorFlow has a specific project that allows you to run it in JavaScript, etc. But the fact is, most of those they have essentially a predefined set of operators. So for instance, you have a model that does some, I don't know, matrix multiplications, and the matrix multiplication is supported in these projects, and so you'll be able to use them. I mean, I'm generalizing. It's they do much more than this, but that's the idea. But however, if you have some custom algorithm written in pure Python, you're not going to be able to run it there because, well, it's pure Python. Maybe use some additional libraries, etc. So, and PyOdide, what essentially where it can how it can intervene is that, for instance, if you do some custom pre-processing, maybe it's just easier to like load PyOdide and do it there than to try to convert it to the supported operations by these tools. And also, like a nice thing about Python and serialization of Python objects is that we have the pickle format. So pickle is it has its downsides and upsides. So the downside is it's unsafe, it's brittle to environment changes. But the advantage is portable and generally not non-opaque, in the sense that you can load it and get the original data that you had. So you have a Python class, you just pickle it, you unpickle it, you get your original Python class. You can inspect what's happening there. And so this, for instance, can be used in the context of PyOdide. So what you could say, you can do is, you can create an environment with the same versions of Python and dependencies as in PyOdide. You need that because otherwise pickles will not be portable. In the case of machine learning model, you just pickle it, and then you can unpickle it inside PyOdide, and you'll get your model as is. And then you can, for instance, because of this foreign function interface, you can, for instance, call it from JavaScript directly. So you have a small walkthrough here. I'm not going to go into it because we don't have that much time left. But of course, so this is still a bit experimental. There's still, let's say, there's still a bit more work necessary to make a particular project that depend on SciPy completely fail-proof. So let's next talk a bit about the challenges that are still there and the roadmap. So the first point is the download size. So this is the main people say, okay, we don't want to download the full Python, right? Like so currently CPython plus the standard library, it's like 20 megabytes. In PyOdide, we can get it compressed, so it's compressed by the CDN to something like 6, but it's still something like it's still measurable volume, right? And that however only happens the first time you load it. So the second time you load the page, it's going to be cached by the browser usually. And and this is due, for instance, to the fact that, well, you have the large standard library, right? So you have the standard library has a lot of things that you maybe don't necessarily care about, for instance, in the context of PyOdide. So for instance, if you have the distutils package, which is like 200 kilobytes. So if you're on your laptop, 200 kilobytes, it doesn't matter. If you're loading it from the browser, the 200 kilobytes that you're not using is kind of a lot. And so there have been like some thoughts about maybe we should make some of those modules like don't load them by default, but load them optionally, etc. So similarly, in the scientific computing space, you have this, you have some packages that are really large. For instance, SciPy has is essentially an accumulation of very different submodules, and you probably don't need all the submodules. You probably need a specific one. So maybe again, there is maybe a question of maybe you can load it submodules independently. So I mean, there essentially the idea is that there's a lot of things that were done in the Python ecosystem that didn't really took too much care about the size that you'll get it then, because it doesn't matter in other applications. However, in the case of PyOdide, we now have all those like questions and wondering what we can do about it to to, for instance, essentially make it faster to load. The problem is not so much size, but also how fast you can load the application. So for instance, if you look at the REPL, it's going to take like around maybe 5 seconds with good internet connection, and that's significant. Other non-limitations, well, there are those of the WebAssembly virtual machine. So first thing, you have no subprocesses. So anything that uses multiprocessing or subprocessing is not going to work. Currently, there is no threading. So that's potentially could be enabled, but browsers need to support it, and browsers enabled support very recently. So we have to wait some number of months or years to make sure everybody uses their recent browser. However, you can use web workers, so which is a kind of a form of running something in parallel in the browser. So to some extent, that could replace creating parallel processes. Another very strong limitation is you have no sockets support. So essentially, you cannot, for instance, make HTTP requests using all of the standard library modules in Python, and that's really unfortunate because well, a lot of Python packages assume you can like use I don't know, requests or use standard library modules. We'll talk about this point a bit later. Well, another thing is it's a 30-bit to 2-bit architecture, which is well, I mean, it's manageable, but it's also adds constraints. You know, in scientific computing, they have like the support for 30-bit architectures is not as good as for 64-bit. And generally, the thing is there are some system calls that are essentially not implemented, for instance, in MScript, and so you can very well do, I don't know, you have some file and you apply some non-standard operation on it, and like you change permissions, right? That's going to fail because it's just not implemented. And then there are some constraints in JavaScript. So for instance, you have no integer type, only like number type or big integer type. There's generally, well, there are some libraries that implement NG arrays, but there is maybe not one that's really standard one. And interestingly, there are some like keywords that are reserved in Python but not in JavaScript. So for instance, if you have an object that's this JavaScript promise, you pass it to Python, and then what you would do is you would want to call then on it, except that then is a reserved keyword in Python. So this is going to be a syntax error, even though, well, that's the method that you would like to call. So it's I mean it's some anecdotal points, but it shows that there are some things when you start to actually try to apply it on actual projects that you're like, how do I do this? And more generally, so if you talk about the roadmap, what we have now is what we would like to get is well, smaller packages and faster to load. So a very simple example is, for instance, all the scientific packages include tests by default inside the package. And I mean, it's useful, but you probably don't want to load that if you load like pandas. Pandas must like probably half of the size is just tests. And we can probably need to extract that at some point during build time or something. So the performance aspect, there is a question of could we maybe re-implement some of the standard library modules, for instance, HTTP client, to use web APIs. So you could actually use HTTP client, but underneath is going to call like JavaScript functions. And some of this is actually, for instance, done in, I think, in Basthon for requests. There's the big challenge of SciPy and Fortran support. So currently we can compile Fortran by converting to C first, but it doesn't work well for all versions of Fortran. So I mean, there are like challenges there, and because SciPy uses Fortran, that's something that we have to deal with. And more generally, there's the question of how do we keep this this package build system sustainable. So I mean, it started as a very simple implementation from scratch of the build system because we had very specific needs. Of course, there is like great communities that exist already, such as CondaForge. So the question is, can we like shift some of this there, but at the same time, while keeping some of the constraints we have that are really non-standard and are very specific to this environment, and like things like threading that could happen eventually. And of course, if you have like if you'd like to contribute something or like be technical or non-technical, we're very welcome to new contributors. So I'd like to thank generally the team, first the team at Mozilla who started this project and started like PyOdide, and in particular Michael Rodboom, the maintainers of PyOdide, and very active contributors. Well, you have a full list on the right, and some of their like partners and related projects who. So, for instance, Casati, who funded some of my development like a few years ago. Well, Basthon project, like Starboard, who are like contributed patches back, and just deliver for allowing us to distribute all those packages efficiently over this again. Thank you. And do you have any questions? I haven't checked chat so far, so I guess there's.
Yeah, I have been sort of there were some discussions in the chat. So let me pick some of the questions. There was one that you answered eventually, so I think I'm just going to skip that. There was a question by Hervé about what happens when you change a variable, like a Python variable, after, or like a JavaScript variable, like in this, you know, sort of reflection mechanism that you have, and whether you see the changes in the other language. And yeah, I'm sorry if I'm not representing the question right.
So that's a very good question. So yeah, so and there's one aspect that I completely skipped here is how do you do memory management? Because in Python you have this, you know, you have a garbage collection. In JavaScript you don't, and so typically, effectively, when you take a variable, you copy it to, for instance, from Python to JavaScript, you're going to access via the reference. So if the initial variable changes, you will also see the changed object. But this also means that maybe the initial object got deallocated somehow, and then you're still trying to access it, or the other way around. You know, so there's really a lot of challenging questions of memory management that enter there, and that aren't really solved yet, and so that's something we really would like help with.
Okay, Unless Hervé asks another question or like a follow-up one, I will move on to, there were a couple of questions by Olivier Grisel. The first one was about native threading, whether it's possible to use OpenMP. And I think you partially responded to that by saying no native threading, but then the follow-up question was like, when browsers start supporting it, will we be able to do this?
Yeah. So I mean, now, like the latest Chrome or Firefox, they do support it. The problem is not everybody has the latest Chrome or Firefox, so that's why we haven't really added yet. But yeah, essentially, you will be able to you can use multi-threading, be it from Python or OpenMP, in C code, because essentially what happens is mscripten implements the system calls. I think the associated system calls, so you can use it no matter from where.
And so would it just work without any change in PyOdide, basically?
Yeah,
if
basically.
You just enable the switch?
I think mostly, yeah. I think there are people who manage to compile it with threading, and I think it mostly works. So I mean, even now we essentially build CPython with very, very little changes. So we just take the source code, we build it, and it works. It mostly works. I mean, you still have a few patches, but it's very minor.
Okay. There was another question by Olivier. Oh, sorry, like the thing scrolled automatically. Could we use the ONNX runtime to run arbitrary Python functions in an ONNX node using PyOdide? So basically using PyOdide for outside of the web browser, I guess, right?
So I mean, to be honest, I'm not. I don't know enough about ONNX runtime to comment on that. So I don't actually know everything you can do with ONNX runtime, but you can. I mean, there are people who managed to build PyOdide outside of the browser. So, for instance, as part of the Wasmer IO project, and so essentially what they have this the standard library for WASM. So you build your project as you would like normally, except that you use a special compiler and a special standard library that's going to like manage all the system calls. So so it's possible. That's not something we have explored too much, but it is possible.
By the way, I just made Olivier a host if he wants to ask the question directly, so to make it a bit more interactive.
Yes.
Hello. Can you hear me? Yeah. Okay.
Yes.
Yeah. So my question was actually, would it be technically possible? I assume that the ONNX runtime right now do not support it, but would it be technically possible for the ONNX runtime that run on the WASM WebAssembly target to actually call into PyOdide to run arbitrary Python function in a node? I assume that it should be possible, but there is a lot of work to do. But
yeah, I mean, it's really a question. Can the ONNX runtime on your laptop call into some Python code? If it can, then it will be able to do that in Wasm as well, I guess.
The spec doesn't allow it, but technically, if you make it possible, maybe they could evolve the spec using an extension. Okay. I have a related question: would it be possible to compile LLVM using mscripten into a WASM machine and then use a number in a PyOdide program?
Yeah, so it's a fairly frequent user request. I mean, I guess it could be possible, but I haven't personally tried it. And I mean, it kind of means you have to compile VM with LLVM. I don't really know what's but yeah, I don't really know how it's going to work, but probably. Yeah.
Okay, thank you very much.
I have a question.
Yes.
So how does it work for the reflection? Do you actually patch CPython C code, or is it like external?
So you mean the conversion between languages?
That's right. Yeah.
Yeah. So essentially what happens is mscripten has capability to export C functions into JavaScript. So that mscripten by default allows you to call like some C code from JavaScript directly without actually doing anything. And so that's what we use. Because Python is just like the core Python is implemented in C. So we expose those C functions that make it possible to call them from JavaScript, and therefore that's essentially how it's implemented.
Okay. There is another question that I actually initially missed, and I just noticed I missed it from Kiko. I think Kiko is the author of Brighton.
Oh, wow.
Or like a maintainer of Brighton. Maybe I'm not.
Okay.
I'm not quite
I hope
sure.
I haven't said anything bad about Brighton.
So, could the work done by other projects like Brighton, Ouroboros, Curb, translating some of the standard libs to JS be useful? Like,
yeah. So no, yeah, definitely. I think those, especially for everything that needs to like communicate with the web or something. Yeah, that certainly that's something that we could explore, because I haven't, to be honest, I haven't really looked in detail or like those aspects, but I think that's definitely something that we should explore. Yeah.
okay, thanks. Let's see. Are there any other questions in the chat? Does anyone want a last chance to? Okay, everyone remains silent. Roman, do you want to add anything?
No, thank you for inviting me, and well, I'm looking forward to hearing next talks.
All right, thank you. Okay, let me share my screen again, and if you bear with me one more sec before I share my Twitter feed, because I was tweeting about this on Twitter. There you go. We have the next presentation is co-presented by Romain Casati and Nicolas Poulain. So Romain Casati is a computer science PhD from UGA, and he's currently a high school math teacher, and so teaching computer science and math in Vierzon in France. And Nicolas Poulain is also a French mathematics teacher and trainer, and is the co-maintainer of the Capytale project. So now Romain and Nicolas, I'll let you the stage. We're not hearing anything here. Maybe you need to unmute.
Sorry. When I share the screen, I can't unmute. So I disable the sharing, then I re-enable it. So can you hear me and can you see?
Yeah, we can hear you well now.
Okay, I put a link in the chat where you can load my presentation from Basthon. So I put it in full screen. Is it working?
Yes.
Okay. So, so thank you, Sylvain, for the invitation. First of all, I would like to apologize for the fact that most of the resources here will be in French. This is because we are targeting the French education, so I would like to be sorry about that. But we plan to translate it to English soon. So it will be in English soon. I will present a project called Basthon, which is mainly how to do Python everywhere. And we will also present with Nicolas, we will present Capytale, which is how to work with Basthon and students and teachers. So you have the link to both projects here. So how boring will it be? First of all, I will start with why I created Basthon. Then we will have a tour of Basthon. We will quickly see how it works. We will talk about limitations, but I think this is mainly the limitations that are presented by Romain. And then this will take about 15 minutes. And for the last 5 minutes, Nicolas will present Capytale, which is, as I said, Basthon for students and teachers. So why I created Basthon? 2 years ago, there is a reform in French education for high school students that say that in science, like math, biology, physics, etc., you have to use Python 3. But we are on our own as high school teachers because we have to deal with heterogeneous installation, with students that doesn't know how to install a Python interpreter, a Python distribution. So we are on our own. There is no real easy to use GDPR compliant and open source solution to teach Python. So this is why I start learning how to develop Basthon. By easy to use, we actually require only an internet connection and a web browser. By GDPR compliance, we want to be full client side. This means this is a static website. We doesn't want to send code to the server. So I test lots of solutions, and each of the solutions have its own strengths and weaknesses. But to our goal, PyOdide seems to be the most advanced solution. So here's a tour of Basthon. I can do a live demo, but when I do live demo, I forgot some stuff. So this is a video. I think it will be okay to comment this video. So in Basthon, you have two front ends, the console and the notebook. So here we will start with the console. At left, you have so here is the PyOdide load sheet. Here you have a script at left. Here we have a square function that we defined. We can then execute the script and use the function in the shell. That's right. So you have nice. It's basically like EUPL PyOdide, but with a script part. So you can have string representation like that. So it's a basic demo of the script part of the front end. So coming back to the main page, you can see that we have a gallery of examples. So here is an example in the console with Matplotlib and NumPy that are used. So you execute the script, and you can see that there is the loading of both modules, and then you can see the graphics outputs that prints the results, that display the results. And then you can change the function that plot, start another figure. You can modify this, and then there is no module reloading, of course. It's real time. So coming back to our main page, there is also specific modules that are not in PyOdide. This is purely teaching stack. This is not the scientific stack in PyOdide. This is the teaching stack that we are interested in. This is the turtle module. So it's actually the turtle module from Python that we use, that we plugged inside PyOdide, and then it produces animated SVG stuff. So there is also documentation. It's in French, so sorry about that. And you can get the philosophy of the project, open source. There is a kernel that is plugged to 3 front ends, a console, a notebook, and a JupyterLab front end. This is basically JupyterLite that will be presented later by Jeremy Tuloup. About the notebook, so we will have an example of how the Basthon kernel can be run in a classic notebook. So here is the PyOdide loading, and this is Folium, which is not basically supported directly, I mean, in PyOdide, but it's a pure Python modules. So we just need to patch it to get nice rendering in our front end. And here you will see the famous Mont Blanc from the French Alps. And all this works client side, of course. And I forgot to mention that you have compilation. So I think I will come back to the notebook just to show you that we have, if we start folium dot and we hit tab, then we have all the compilations that. Here is an example. This is purely PyOdide, but just to show you that since we are not in a web worker, that we can interact with the DOM and break the front end actually. We have also implemented the request module. It's basically Ajax request. So this seems to be a Python module, but it's actually called JavaScript from PyOdide. Then we get some CSV file from this request, and then we load pandas. That's dependent on NumPy, so this is because this is why it's a bit long, just to show you that data frames in pandas are nicely rendered in our front end. Then coming back to the turtle module, we managed to teach our turtle how to handwrite. So our turtle is able to handwrite Basthon. So this is just a baseline example that we show here. Actually, the turtle module is really appreciated by our teachers because it's a nice way to teach how to program. Another module that is not present in PyOdide is GraphViz. Here it's a WebAssembly compilation, not by Basthon, but a WebAssembly compilation of the GraphViz library that is called from PyOdide. So as you can see, you have a PNG, SVG output, and it runs nicely. And this is not part of PyOdide. We have also an integration of p5.js. You write Python code, and the Python code calls p5.js for you with a setup and a draw function, and you can have nice 3D results like this. We have also other P5 examples. There are also, this is fire simulation. It's a bit slow. It's not really real time. It's a bit slow because during the simulation, I have the screen recording. So this slows down my computer. But it's more real time if you use it. It's in the gallery, so you can test it. Another P5 example, just to show you that it also works out of the box in a notebook. So it's a particle simulation. So there is a setup and a draw function with a particular class called ball, and that's managed the interaction. I think we have another example here. This is a purely teaching module. This is not up to be implemented in PyOdide. This is really for our purpose in Basthon. This is called Python tutor. This is not our module, but we integrate it in Basthon. You just call the tutor function in the cell, and it produces this nice rendering of step-by-step execution. At left and at right, you have the stack visualization, what's happened in memory. If you have linked list, it can show it. If you have dictionary, etc. Yeah, this is yeah. Just to show you about Python tutor. In Python tutor, actually, you submit your code. The code is run on a server. So the Python code is on a server, and then you get back a bunch of data that is used to produce this nice rendering. This is how Python tutor works. And what we do is that we took the code that is run on the server, we run it on PyOdide to make it full client-side, and we get this bunch of data that is used for the rendering from the browser. So it's Python tutor full client-side. That's it for the tour. So there is other functionalities that are not presented in the video. This is about you can share some script and some notebook via URL. So if it's not too long, then it will work. It will compress your script or your notebook and create a URL that is not stored. It's not a tiny URL stuff. It's really putting the data in the URL. And it's an easy way to share small notebooks and small scripts in Basthon. So you can see, you can have more details about that in the documentation. You can submit user modules. So if you have dependencies on modules that you wrote yourself, then you can put it, you can store it somewhere in the web, and you can give it in via a param in the URL, and then it will work. It will be, the dependencies will be loaded, and it will be importable in Basthon. And you can have users files that can be submitted, CSV, images, text. If you want your notebook to work on external data, then you put the link to this data on the URL. How it works? So I will be, maybe it's not very technical. This presentation is not very technical, but you can go deeper in the details and technical details in the questions. But just to let you know that Basthon kernel actually uses an event-based API. It's actually language and front-end agnostic. This API is quite close to the Jupyter messaging one. You have execute request, you have execute reply, and for those who knows, it's really close. But it's not messaging, it's event-based. It's quite easy to plug to new front-end, to new languages. We have implemented quite easily new languages like SQL, JavaScript, OKML, and stuff. If you fulfill the API, then it will work out of the box in our 2 front ends, even 3 front ends. So it's quite easy to extend. And just to say that the Python part of the kernel is actually a PyOdide module. This means that we use the PyOdide toolchain for building our module. It means it's loaded like NumPy, it's like all modules that are not standard library. You load the Basthon module and then it actually loads the kernel. So our kernel is actually written in Python mainly. So this is just a simple schema, but actually the first part was already presented by Roman. PyOdide is actually the Watson compilation of Python plus some modules. We build our Basthon kernel on top of that with JavaScript and Python stuff. And our Basthon console and Basthon notebook just react with this kernel with some JavaScript events. So we have plenty of limitations. Most of them have been already mentioned by Roman, but we have some limitations that come from the fact that we are on a browser. So you can have course issues if you make requests. You have I/O, sync and async is difficult, but just threading is not supported. So we have all this stuff of limitation. We have some limitation from the consumption choices. We wanted it to be GDPR. It does not mean that you don't have to send code to clients. It does not mean that. But to be GDPR, we want it to be full client side. So it's hard to get code from to a backup of the code on the server because it's purely static. So these limitations are mainly bypassed by the Capytale project that will be presented in a few minutes. And there is also limitation to support the Python ecosystem. Even though the PyOdide project, to my point of view, is the one that it's the better in in the integration of the Python ecosystem, you have several modules that are really hard to integrate to PyOdide. So it will not be as easy as P for Conda install, of course. So I think it's the end of my part. So I will let Nicolas to present the Capytale project that is built on top of Basthon. I just would like to thank the Pydata community for hearing me, and also the PyOdide community that is here represented by Romain. So really thank you to both communities.
Okay, thank you, Romain, for this presentation. Now I will introduce a use case of PyOdide and particularly Basthon in an educational environment. Let me share my screen. Here we are. Okay. So 3 years ago, we initiated the Capytale project, allowing teachers to create and share Python coding activities with their class in high school. The students can modify a copy of the masterwork of the teacher, and then the teacher can review and grade the work of his students. All data is saved in the cloud. The aim is to provide a working environment on notebooks without installing anything, Python, or having to manually share IPNB files. The first version of Capytale was based on JupyterLab and a tool called NB Hosting, a sort of binder created by Thierry Parmontelat from the French Institute INRIA. But as the project grew with an increasing number of users, the server began to experience difficulties, and users were complaining about slowness. This, despite our efforts on upgrading the hardware. It was time for a paradigm shift, so we met Romain Casati 6 months ago to try out an integration of Basthon into Capytale. The hope we had was that Basthon could handle a significant part of the server load, delegating the Python execution to the browser instead of our servers. The Basthon and Capytale projects have been adapted this way to that new goal on last December and January. 5 or 6 months ago. Today, we have a full integration of Basthon into Capytale, and we count more than 25,000 users in almost 800 schools running Capytale, and the majority of uses involves Basthon from now. The feedback is very positive. As with Basthon, the loading time has been divided by more than 2. From 15 seconds with the binder project to less than 6 seconds with Basthon. Moreover, the load on the servers has considerably decreased. That made us able to offer the service to the many school districts that requested it all over the country. This would not have been possible for us with our previous technology with JupyterLab and NB Hosting or binder because of money. A few limitations, however, with Basthon, as Romain said, with modules, because not all available. But for what we need for our use in high school, we already have almost everything, and the list of supported modules grows very fast. So we're happy with that. A conclusion: after 5 months of use of Basthon into our service Capytale, we can say that executing Python in the browser is first effective, because we can see thousands of users every day. It's cheap and ecologic. We don't need anymore an expensive and energy-consuming server, and very scalable. That's the most important part. We just have to look at the bandwidth to permit kernel download freely for every user. It's okay. I've finished my presentation, and if you have questions about Capytale or Basthon, Romain and I are available for every question. Stopping share of my screen.
Thanks. I think there were quite a few questions actually in the chat. But first of all, I must say that over 26,000 users for a single Jupyter deployment is quite an impressive number. So kudos for that. So there was a question by Roman Yurchak, but I think he's a host, so he can probably ask the question himself.
Yes, I mean, it was a more technical question. So you say that, when you encode your notebook in the URL to share them, I guess there's a limitation on the size that way, or is it big enough?
No, there is a limitation. Actually, I can't answer what is the limitation because the limitation depends on the browser, so on the version of the browser, and it also depends on the web server. So some web server will refuse the request if the URL is too long, and some browser will refuse to manage the request if it's too long. So I can't. But I mean, it will work for. I managed to use it with 2,000 line script, but for a notebook, actually it grows quickly. If you take care of the output of your notebooks, I mean, if you delete all output just before sharing your notebook, then you can have a quite big notebook, unless you have Basthon by 64 images that are in the notebook. So it could be quite big, but it depends on a lot of parameters.
So actually commenting on that, playing with this, encoding stuff in the URL, I think the web standard only says that you should support at least 2,000 characters, which is almost nothing, but most browsers take a few kilobytes. So yeah. There was another question by Romain Primet, which is about persistence. Like, can Basthon persist data remotely using like a remote Git server or S3 buckets?
I can't. I don't understand the question. Can Basthon persist data remotely? You mean make a backup of the data that are produced by the Python code? Is that, or?
Well, I think you can have answered the question with your REST API implementation. Maybe this is a way to answer that. Like you actually store notebooks on the server, right? Okay,
yeah, but it's really done in Capytale. It's not done in Basthon itself, but in Capytale, what we have is that you can save a notebook. You can attach some file to the notebook, so it's a kind of cloud. It's not Git underneath, not Amazon S3. It's actually a Drupal server. The notebooks are stored in databases, and the files are stored in the file system like classic file, and they are accessible via URL. But we take care of this, and we load the external files, the attached files. We load them in the mscripton virtual file system. So this means that if you have attached an image, for example, to your activity, then it will be accessible in the current directory in Python. So this means if you want to do loading of this image and render it in the notebook, then it will work out of box, and you don't have to take care about this URL, do the request. Basthon and Capytale do the request for you. So I hope this answers the questions.
Yeah, I think it does. There was a question about whether it's possible to install Capytale outside of the capital. Like essentially in other academies or elsewhere.
We provide the service for other academies already. You have to contact between academies. I don't know the English word for that. Les académies have to contact them, each other, and then sign a paper to share the service between them. It's already done.
Just to mention that if you want to try Basthon on your own web server, then on the Basthon webpage, you can find some zip file that you get them, you put them in your web browser, and it will work. It's not Capytale, but you can try Basthon on your web server. If you think that our server will be full, then you can use it, but it's not full.
Nice. So I don't think there are any other questions. So let's move on, actually. So I'll share my screen again real quick to introduce our next and last speaker. So our next speaker is Jeremy Tuloup. He's a scientific software developer at Quantstack and a core Jupyter developer. He's very active in the JupyterLab and Voila projects. And Jeremy was recently honored with the Jupyter Distinguished Contributors Award in 2021. And Jeremy, now is your turn.
All right. Hello, everyone. So let's share the screen. Okay. So today we do a quick demo of a very new project called JupyterLite. And JupyterLite is what we call it a WASM-powered Jupyter running in the browser. And to greet you all, we're just going to do a little hello world right now. So you can find the repo on GitHub. It's right here. And I think we are almost at 1,000 stars. So if you want to click the star button, feel free and reach 1,000 maybe today. So what you find on the README is like a couple of links to directly try it in your browser. So we're going to do just that. So if we click this link, we go directly to a website, and that is actually read the docs. So there is a demo site that is always available for JupyterLite, and that is served by read the docs, and you can play around with it. So this one that I have here is also on read the docs, but it's using a different front end that I find a little bit better for like this kind of presentation. It's using a new recently announced front end called RetroLab. That is actually a distribution of JupyterLab using the lab components, lab extensions and plugins and things like this. So I'm going to go through this notebook and show you a couple of things. So now we're talking about browser-based interactive computing, just like in Basthon. But here we are using, once again, the lab components. So so we get the thing we expect from a Jupyter frontend, and we are using a kernel called PyOdide, which is actually based on PyOdide, which was presented earlier. So a little bit of history. So this is not that new in a way. So JupyterLite is more like of a reboot of many attempts of doing this kind of things. And one of the first was a project called Jive by Nick Bolveg, which was doing something similar, but with a slightly different approach, more like a top-down approach, trying to patch a lab instead of building it from the bottom up. And here we have a screenshot of Jive running a Python kernel, and there is also like a couple of other kernels, JavaScript, P5, and so on. So this was one of the first ones. Then we also had the P5 notebook that was an attempt of doing JupyterLite, but mostly focused on P5. So we kind of find like the similar components, but very, very, very minimal interface. So at some point, a P5 notebook will be based on JupyterLite, but for now, it's still its own thing. We have Basthon that we talked about earlier. There is also Starboard that was mentioned in the first presentation. And there is also Observable, which is something a bit different than Jupyter. So it's more based on reactive programming. And it's also quite interesting, but different paradigms. So with JupyterLite, we get Python kernel, a JavaScript kernel that runs in an iframe. The notebooks that you interact with are stored in the browser local storage or in IndexedDB if it's available. You can save your settings. You can also have multiple kernels on a page, code consoles, change your themes, and also basic support for some of the visualization libraries. So we can just open the lab interface so we can have like more space to play with all of this stuff. So here you get notebooks, consoles, and a bunch of other things. So on this demo website, we have the tour extension that you can use if you want to discover the JupyterLab interface. It gives you like a little tour, tells you what the UI does and things like this. So let's skip it. But you also find like other extensions. For example, this one, the JupyterLab Draw.io. So if you open it, you can start drawing diagrams and then save it. Then you can close, and then you can open it again and you find it again. So this is also another extension that we just reuse as is. So there was no modification needed. It just works as a JupyterLab plugin. And yeah, you can manipulate files. So here you have, you can create a new folder. You can, for example, move this new file here, and then you go in the folder, and then you can also open it from here. You can move it back up if you want. So it really feels like a real file system, but all of this goes to the local storage in the end. So on the default website, so if you actually open the same URL, you would get this examples folder. I have a couple more here, but that was more for like the playing around and also like trying things on my browser. But if you go here, let's see. Yeah, let's open the JavaScript one. So this one is very simple, but it's just to show that JavaScript works in an iframe and you do like this kind of JavaScript things. You can also have markdown cells. There is also a P5. So this is not P5 in Python, but just P5.js. So you can execute all of this. And then there is a little magic to show the sketch. You can tweak some values and then show the sketch again. So let's do this. And then we have a little demo of PyOdide, which is again based on PyOdide, but it's just a little wrapper. It adds a couple of things. And one of the things is a very simple display module that we can use here to show HTML, Markdown, LaTeX, matplotlib figures, pandas data frames. So here we define the data frame in this cell. It takes a little while. Then we show it again here. So let's wait for it. Yeah, and since it's JupyterLab, you can do a right click and you can do a create new view for output, and you could keep it here if you want. Another thing you can do. So yeah, one thing to notice is that this kernel runs in a web broker, and that is intended, but still we can do a network request using fetch. So here we fetch some data from HTTP bin, and we get a JSON response. And the cool thing with Lab is we can use the JSON viewer, so we can inspect the request like this if we want, and use all of the different MIME render extensions that already exist in JupyterLab. And finally, SymPy, which is also available by default in PyOdide, can also be used here in the lab interface. And it renders pretty nicely. So yeah, matplotlib we already looked at. Renders, there is a couple of other renderers from JupyterLab. So again, those were just installed as this new system of pre-built extensions that was added in JupyterLab 3, and then loaded on the fly. And then you can get support for GeoJSON. So this is a bit zoomed. Yeah. Faster, but then you can also do something else, like if you want to open this file, it also shows you the GeoJSON file as a map. There's also support for Vega plots here. And recently we had an example with Altair. So someone contributed a little code snippet here to get Altair to work in JupyterLite. So unfortunately, one of the dependencies is not a pure Python wheel anymore. So it's still pinning to an older version. But once we install this, we can get some charts. We can install the data set. And we can also have interactive visualization. And I think one more. So I think you could pretty much just, let's see at the very top. Yeah, if you go to this website here, the gallery, I think copy pasting the examples might just work once you have this little bootstrap code here at the very top. So if you want to play around with some things in Altair and get some nice visualization, it should be quite convenient to do. And yeah, so if you have a CSV file, you can double click it. It opens like this as a CSV. Yeah, and from a couple of hours ago, I think someone also contributed this example on the repo. So you need to also do a bit of a micropip magic in the beginning. But once you have this, you can import Folium and also show the Folium maps. And this one required also nothing because JupyterLab can display them by default. So yeah, that was a little tour. So yeah, again, you can also open PNG files like this if you want. And yeah, so let's go back to this notebook here. Yeah, talking about use cases, I think they are quite similar to the one that Basthon also covers. So you have a lightweight Jupyter frontend running in the browser. There is no need for a server. Well, a server serving static files is pretty much it. No command line, no dependency management, all of the tedious things. And it also boots pretty quickly. It boots pretty much in seconds. So the one we were using is on read the docs, but there is also, so if you open this repo here, it's a very small demo. And it has just a couple of files, and all of the logic is pretty much in the GitHub action here that fetches a new the release of JupyterLite and then extracts it, and then just use an action to put it to GitHub pages. So if you go back here and you click here, then you get your JupyterLite website deployed automatically on GitHub every time you commit to the main branch. So yeah. Then yeah, education was also of course covered by Basthon and the Capytale project, but I wanted to just show this quick video that Paige Bailey posted on Twitter a couple of days ago. That is kind of a mock-up using JupyterLite of what GitHub could look like if we had interactive notebooks directly like on GitHub. So it could be really nice to have this kind of feature at some point on GitHub, because you could just point students to a repo and they could just start playing around with it without doing anything at all, not even opening a new tab, because it would just be right there when they arrive. So yeah, that's quite cool. I don't think there is any code for this. It was pretty much just a mockup, but still quite nice to see this kind of ideas around. Yeah, so this is not yet a reality, but at some point it should be possible to build your own static frontend. So for now you have, let's see, yeah, so this demo site is JupyterLite plus a couple of extensions, but ideally there could be an exporter so that you could specify a lot of different things like extension settings, content, and more. And then you could just click a button and then you get this zip file that you could deploy somewhere else. So this was a mockup by Nick Bolvec, and I think it would be really great to to have at some point, yeah, to just make it easier for anyone to just customize their own JupyterLite deployment. Another idea of JupyterLite is that we can start reusing some of the main components, like the TypeScript components, in other projects. For example, Voila, the Quest frontend, and other lab-based applications. And when it comes to deployment, so we already covered GitHub pages and with the docs, but it should also work pretty easily on GitLab pages, also on Binder. Actually, JupyterLite also has a Binder deployment as using the Jupyter Server proxy if you want. And we also had a Vercel deployment at some point. So all of this will be documented here soon. But if you also want to contribute on documentation for this on another platform, feel free. So yeah, for example, Netlify, Nginx, and Heroku. So yeah, anything that can serve static files pretty much works. So yeah, a quick note on, let's see this. Yeah, on the way this thing works. So JupyterLite is pretty much like just a set of plugins. So everything is a plugin. So JupyterLab itself is already a lot of like 70 plugins by default. Also, we have this new lab distribution called RetroLab, which is also a JupyterLab distribution. We're using a lot of plugins from lab, but also having its own plugins. So all of this goes in the this thing we call the front end. So yeah, what runs in your web browser, but there's also a JupyterLite part that also runs in the browser. That is also based on this plugin architecture, which is exactly the same as the one that Lab uses. So Lab uses this Lumino plugin system, and there is this similar system on the JupyterLite. So here you see that, for example, the contents module, the sessions, the kernels, all of these are plugins. And that means that if someone wants to use something else for the contents, so they don't want to store it in local storage, they could, for example, swap it for something else. So swapping plugins is very common in JupyterLab. So very often people provide like different plugins for like the file browser or things like this. So here they could provide something else for the contents manager, for example, that stores files on S3 or a remote server. And using this plugin system, we can also support more kernels. So we have by default 3 kernels. It's just, they are just in the same repo for now, just to make it easy, but at some point they might be moved to other repos. Maybe there will be only 1 kernel supported by default. Let's see. So yeah, Python kernels, JavaScript kernel, pretty much anything that could run in a browser. So this is one of the thing, like one of the goals of JupyterLite is also to be very agnostic, just like Project Jupyter in general. And like Romain mentioned earlier, Basthon also works in JupyterLite, so that's quite nice. So it kind of validates all of the approach on both JupyterLite and also on Basthon. So that's really good to see this these components working together. So yeah, JupyterLite is pretty much based on JupyterLab components, like we already discussed. And yeah, if you play around with the demo, you might see some little oddities, but that's normal because we are using the very latest packages. So currently at Alpha 11, that was released yesterday. So at least we get all of the cool stuff and the new features, but there might be some issues still. So yeah. One of the cool features coming in JupyterLab 3.1 is real-time collaboration. And there is a pull request open here on the JupyterLite to also enable this in this application here. And yeah, so if you look at this this GIF, you see that actually on the left you have JupyterLab open, and on the right you have RetroLab, and both can actually talk to each other, so you can collaborate on the same document using 2 different interfaces on JupyterLite. So you don't need to do anything else, but just go to a URL. And I was wondering, maybe, let's see, I don't know how much time we have here, maybe. what we could do is, let's see if I do this, and I paste this link here in the chat. I don't know if you get it, but maybe we will see, I think, soon enough, right? So if you open the README and then you go, yeah, so if you follow the link and you open the README, maybe we will see each other. So yeah. So yeah, still a couple of issues. I see a new cursor here. So I think the document, yeah, the document might be reloading every time someone joins, but yeah, nice to see some people. Cool. I mean, that's also the risk of like demos, right? But I mean, it's also fun. So yeah. Okay, so yeah, so what's up next? We are currently focusing on an MVP
Jeremy,
project.
I want to see a screenshot of that again. I want to tweet that.
Okay, sure.
Please.
I mean, we can also go to maybe a notebook if you want. So
yeah, it's even better.
Yeah. Actually, some people could stay in the README file, and while others open the. So you have to open the notebook with the same name, because this is how the room is kind of created. So this is how users are grouped together. But here you might see a little issue with new sets created, but I think it should work otherwise. Yeah. Let me know when you're done with your screenshots.
It's done. Thanks.
Okay. Yeah. Okay, so if someone feels adventurous, can open the PyOdide notebook in the examples repo folder, but otherwise it's fine. We can move on. Yeah. Yeah, there is someone here. Yeah. This is a test, but you can actually do printing here, execute, and then I think the outputs will also be synchronized with everybody. So all of this is really, yeah, I want to insist on this. It's really just reusing a lot of the work that was put in JupyterLab, and that was put by Kevin, Eric, Carlos, and everybody who worked on RTC before. So that's it's really great that we can just reuse that almost for free. So yeah, probably going to close this. It seems to be a little bit glitchy at the moment, but yeah. So yeah, many thanks to everybody who could make this possible. Yeah, so MVP project. So the goal is to have something that kind of is, the first version. So there are still a couple of things to improve. The tooling, people should be able to write SilverLite extensions. So that means something that extends the server part of JupyterLite that still runs in the browser, but still. And some ideas are new kernels. For example, one that is powered by WebAssembly, which is SQL.js. Maybe another one powered by XusPython, if we manage to compile XusPython to WebAssembly at some point. Maybe alternative content manager, like we already talked about, authentication, and even remote kernels running somewhere else should be possible. Like if you have one running on Binder, a little bit like the ThebeLab project does. So that should also be possible. It could be very fun to see. A lot of tools to go into the deployment direction. So everything that could make deployment easier, especially when it comes to reusing JupyterLab extensions and also sharing content and data easily. So for now, you have to do the copying by hand. But yeah, it's very new. We haven't got like the tooling in place yet, but normally it should be possible to do this. And of course, I think a lot of that will just reuse what is currently done in JupyterLab already. So yeah, Jupyter widgets also coming at some point, hopefully. Plotly is almost there, so it displays, but I think there are some issues with IPython, so maybe something to look into at some point. Maybe something that could also be shared between Basthon and JupyterLite is like a common IPython that will run in the browser. That would be great to have. So yeah, many thanks for listening, playing with the demo, to Nick Borbeck, who contributed a lot to the repo, and everybody else who also contributed in many different ways. So yeah, thank you.
Wow, I was literally blown away by the real-time collaboration. I mean, the fact that it was possible to enable it right away. There was a question by Olivier, but I can let him respond. Actually ask the question himself.
The question was, do you use CRDTs, conflict-free replicated data types as the data structure to enable collaborative editing, like from a theoretical point of view?
Yeah, so it's completely based on a library called YJS that is authored by Kevin Jans that we work with. I think if you go to the JupyterLab repo, you might see some more information. So yeah, if you go here, maybe search for shared editing. Yeah.
So yeah, collaborative editing just landed in JupyterLab.
So it's based on the JupyterLab default component, and it's actually enabled by JupyterLite without changing anything, or?
Yeah. So one thing that changed is, and it's very minimal, and thanks again to the plugin system, is JupyterLite uses a different provider. So sorry for all the code, but instead of using the default WebSocket provider that is in Lab, that is also talking to endpoint that is part of Lab, JupyterLite is using a WebRTC provider. So in the end, you will end up with the plugin that looks like this. So maybe it would be better to show it on a different, yeah, like right here. So if you, yeah, this is pretty much real-time collaboration in JupyterLite. Yeah,
that's very impressive.
Yeah, it's quite.
Thank you very much.
Quite nice. Yeah.
Yeah, very nice demo and a very nice presentation. Thank you very much.
So I don't see any other questions, and so I think this is it. I'm going to actually stop the recording.
Just maybe one question from
yeah.
So do you have any like difficulties from the fact that you're running in a web worker? Like, do you have to like serialize objects back and forth? How does it? What's your experience with it?
Yeah. So the kernel speaks almost all of the Jupyter protocol. So yeah, messages, they go, they flow as JSON, JSON blobs. But the main difficulties I think are, for example, matplotlib at the moment requires a little patch because we can't use the default backend that is available in PyOdide. But there are like some IDs to make it work in the web worker. But yeah, I think the main reason for having it in a web worker was to, open lab here and have actually multiple kernels. Like I forgot to show that, but here, if you go here, like just like in JupyterLab, you could open a previous kernel if you want. So here, and it's still in memory. So here, normally, if you execute it again, yeah, execution count is changing. So you kind of pick up where you left. And having it in a web worker felt like the most natural. But of course, using the plugin system, it's definitely possible to just have something that is not in the web worker. And I think that is how the Basthon integration is currently working with JupyterLite. Yeah.
Thank you. Great work.
By the way, the JupyterLite reached 1,000 stars.
Nice, thanks, starring.
And so the number 1,000 is Romain Casati. And so, yeah, which is pretty cool. Congrats on this.
Okay.